Hello and welcome to another in my series of videos about basic logic. And this is what it's all been leading up to. In this video, I'm going to take all that we've talked about in the previous videos about symbols and conjunctions and conditions and truth tables and all that, and put it to use evaluating arguments. And the kind of arguments we're talking about here, it's not the kind where you try to intimidate somebody into coming around to seeing things your way. And it's not the kind of argument where you're making an emotional appeal to someone. In fact, it's the opposite. We're trying to get any emotional distractions or assumptions out of the way so we can focus on the logic. Logically, what must be true? And I could start by trying to explain in general what logical arguments are, how they work, how they're structured, that sort of thing. But I think it would be easier to jump right on in with an example of an argument. Now, this example might or might not be a good argument, a valid, logically valid argument. See if you can decide whether or not it is a valid argument. Is this a valid argument? The person who broke into Mrs. Higgins's house wears size 8 shoes. Lyle wears size 8 shoes. Therefore, Lyle is the person who broke into Mrs. Higgins's house. Now, the first two statements here are the premises of the argument. They're the things that we start out knowing or believing or assuming to be true. And then the last statement is the conclusion. So in this argument, we're claiming that the conclusion must be true because the premises are true. If this is a good argument, a valid argument, then knowing that the two premises are true guarantees that the conclusion must be true. But is it a valid argument? Well, let's try translating it into symbols so we can focus on the logical structure of the argument. So the first statement said that the person who broke into Mrs. Higgins's house wears size 8 shoes. And we can really think of that as a conditional. If broke into house, then size 8 shoes. So if Lyle is the person who broke into Mrs. Higgins's house, then Lyle wears size 8 shoes. That's a conditional. So we can symbolize premise number 1 as if P, then Q, or P implies Q. Then the second premise was that Lyle does wear size 8 shoes. That's what we had the Q standing for. The P stands for Lyle is the person who broke into Mrs. Higgins's house. The Q stands for Lyle wears size 8 shoes, so that's what premise 2 would be. And then our conclusion is that Lyle is the person who broke into Mrs. Higgins's house. And that's what we had P standing for. So here our conclusion is just P. So if this is a valid argument, that means that if premise 1 is true and premise 2 is true, then the conclusion must be true. If P implies Q, and if Q is in fact true, then P must be true. At least that's what the argument is saying. Now, is that right or wrong? Is it true or false that P implies Q and Q together imply P? If it's true that P implies Q and that Q is true, does it necessarily follow that P is true? Let's make a truth table. Remember, we got to have a row in the table for each possible value of the simple statements P and Q. So that's 4 rows altogether. We'll start by noting down the value for each row of if P then Q. So if true then true is true. If true then false is false. If false then true is true. If false then false is true. So that's this part of it. And then we need to AND that with Q itself. We need to evaluate the conjunction where we're taking if P then Q and Q. So for each row of the table, look at the value of if P then Q, look at the value of Q, and AND them together. Take the conjunction. So true and true equals true. False and false equals false. True and true equals true. True and false equals false. Remember, for the conjunction to be true, both parts have to be true. The first thing and the second thing. Now, we're going to take care of this whole thing. The whole thing is a conditional, where the if part, the antecedent, is what we just evaluated. If P then Q and Q. And the consequent, the then part, is P itself. So focusing on those and evaluating the whole conditional, if true, then true equals true. If false, then true equals true. If true, then false equals false. If false, then false equals true. So the value of the whole thing is shown in this last column of the table. True, true, false, true. And since one of those values is false, that means this is an invalid argument. Look at what that's telling us. That's telling us that there is a possibility, there is a row on the truth table where P implies Q is true, premise 1 is true, and Q is true, premise 2 is true. So premise 1 and premise 2 are both true, but the conclusion, P, is false. And if there's any way for the premises to be true, but for the conclusion at the same time to be false, it's not a valid argument. So this argument is invalid. Just because Lyle wears size 8 shoes doesn't mean that Lyle must be the person who broke into Mrs. Higgins' house. He might be, but it might be somebody else who also wears size 8 shoes. Here's another example. At first it might look the same, but it's subtly different. So this argument goes like this. The person who broke into Mrs. Higgins' house wears size 8 shoes. Maynard does not wear size 8 shoes. Therefore, Maynard is not the person who broke into Mrs. Higgins' house. What about this? Is this a valid argument? Well, let's analyze it the way we did the last one. If we translate it into symbols, the first premise is a conditional. If Maynard is the person who broke into Mrs. Higgins' house, then Maynard wears size 8 shoes. If P, then Q, with P standing for Maynard is the person who broke into Mrs. Higgins' house, and Q standing for Maynard wears size 8 shoes. Premise 2 is that Maynard does not wear size 8 shoes. So we had Q standing for Maynard wears size 8 shoes. This would be the negation of that, not Q. And then our conclusion, therefore, Maynard is not the person who broke into Mrs. Higgins' house, would be not P, because we had P standing for Maynard is the person who broke into Mrs. Higgins' house. So there's our argument in symbolic form. If P, then Q, not Q, therefore not P. So to decide whether this is a valid argument, we need to know if P implies Q is true and not Q is true, then not P must be true, right or wrong? That is, if we set up premise 1 and premise 2 implies conclusion, does that always work out to have a value of true? Here, premise 1 is if P then Q, premise 2 is not Q, the conclusion is not P. So we need to look at a truth table for if P then Q and not Q implies not P. So fill in the values for P and Q individually. Work out the value for if P then Q. So if true then true is true, if true then false is false, if false then true is true, if false then false is true. We're going to need the value for not Q, so look at Q and just take the opposite or negation of that. Not true is false, not false is true, not true is false, not false is true. Now we got to AND those two things together. True and false equals false, false and true is false, true and false is false, true and true equals true. The conclusion is not P, so let's write down what that is for each row of the truth table. Look at P in each case and take its negation. Not true is false, not true is false, not false is true, not false is true. And finally, take if the antecedent, then the consequent. If P implies Q and not Q, then not P. So if false then false is true, if false then false is true, if false then true is true, if true then true is true. Well, look at that. It came out all true. And that means, well, when a logical statement is always true, we call it a tautology. And in a case like this, where that represents an argument, if we end up with a tautology, that's what tells us that the argument is valid. So to check whether an argument is valid, you can set up a truth table for premise 1 and premise 2 implies conclusion. And if that truth table turns out to give you all true values in the last column for the whole thing, the argument is valid. Otherwise, if any of these came out false, then we'd see that the argument is invalid. So to evaluate an argument, you can make a truth table like this. Now, there are certain logical forms or setups or symbols that are so common and basic that if you remember them, you don't always have to go back to your truth tables. You can say, aha, I've seen this pattern before. I know that it is or is not valid. So in the next video, we'll look at some of the common forms of valid and invalid arguments to watch out for. To end this video, let me just point out that this is how we would check it with a truth table. But to say that an argument is valid doesn't necessarily mean just by itself that you have to accept the conclusion. It not only has to be a valid argument, but the premises also have to be true. If the premises aren't true, all bets are off. So an argument can be a valid argument, but have a false conclusion if one or more of the premises is false. To say the argument is valid just means that if you know that the premises are true, then you know that the conclusion must be true. Now, a sound argument is one where not only is it a valid argument, but you know that the premises are in fact true. And in that case, that's enough to guarantee that the conclusion must be true. It's also possible to have an invalid argument with a conclusion that turns out to be true. So, if Abraham Lincoln was a president of the United States, he was an American citizen, true. Abraham Lincoln was an American citizen, true. Therefore, Abraham Lincoln was president of the United States. Well, that is a true statement, but those two premises aren't enough to guarantee that it's a true statement. They're not enough to explain why it's true. You can replace Abraham Lincoln's name with your own name, and it would be true that if you were president of the United States, you're an American citizen. And, well, maybe you're an American citizen. If not, don't worry about it. But if you are, then the second premise would be true. So you would have true premises, but unless you happen to be the president of the US and watching this video, the conclusion would be false. So like I said, next video I'll come back and we'll look at some common forms of logical arguments.